Okay, binomial expansions with surds. Well, to do this we need to revise just very quickly some other concepts in surds and multiplication particularly. So really quickly, if we have something like in the form of a root b multiplied by c root d, so something on the inside, something on the outside. Remember that we multiply the outside bits together, and that is still multiplied by the inside bits together. So in this case I end up with a c on the outside and bd on the inside. If that had numbers in it, that could be something like 2 root 3 multiplied by 3 root 5 would end up looking like 6 root 15 after we multiply all the bits together. So that's the first thing to note. Secondly, we should just note what having brackets and algebra usually means. And it's just that when I multiply bits by each other, they end up being multiplied one at a time. So the a on the outside simply implies multiplying everything on the inside by a. If I have something in the form of the binomial, which is the main target of today's work, then whatever I've got here now says both things in the left-hand bracket multiply into both things in the right-hand bracket, and this time we have to be particularly careful about negatives and positives. So I end up with the a times the c, I end up with the a times the negative d, I end up with the b times the c, they're both positive, and I end up with the b times the negative d, and whatever that is equal to. And just having to be really aware of those as I go. So using those little pieces of logic there, we need to look at some other questions. So if I've got something, not yet a binomial, but something on the outside and something on the inside, what have I got here? 3 multiplies by the 1 on the outside, leaving me 3. Root 2 multiplied by root 2 is now just 2, so that's going to be 6 when I get to the next line. The 3 multiplies by the 4, giving me 12. The negative is still there. The 2 multiplies by the 5, giving me root 10. So now I've got 6 minus 12 root 10, and that's going to be the end of that question there. Let's have a look at another one. 5 minus 3 and 7 minus 2 root 5. So this is in the form of the just straight out expansion that we've got on the left hand side there. So I've got 7 times by root 5. Well, the 7's not in a root, so it multiplies by the 1 that's on the outside of the other one, that hidden one sitting just there. So the 7 multiplied by the 1 gives me 7 root 5, and then I'm multiplying that same 1 root 5 by the 2 root 5. Now this time the 1 multiplies by the 2, the negative multiplies by the positive, so I've got a negative there. I've got a 2 on the outside, but root 5 times by root 5, that's just 5. So I get 5 there. I'll simplify that on a new line later on. Okay, I'll move on to my next two things to multiply together, which is the 3 and the 7. There's a negative there, so I get 21. And then the 3 is outside of a root, so I'll multiply it by the 2 outside of a root. And I've got minus times minus is positive this time, so 6 root 3, 5, 6 root 5. Now as I look at this, I've got some like terms. I've got a root 5 here, and I've got a root 5 here. So 7 plus 6 is 13. Root 5. I've got a 10 here and I've got a 21 here. They're both negative, so that's minus 31. Okay, let's have a look at another question. If I've got something in the form of 4 plus 3 root 2 all squared, remember what all squared means here. It actually means 4 plus 3 root 2 multiplied by exactly the same thing, 4 plus 3 root 2. Now we could go through and multiply that out exactly the same as we've done before, or we could remember another rule, and that is that any time I have something squared, that's equivalent to a squared plus 2ab plus b squared. Now, if you're not sure of where that comes from, just go through and multiply the parts out. Oops, not squared. So what are we getting there? A times a is a squared, a times b is ab, a times b is ab, and there's my 2ab. B times b is b squared. Now, since we know that that's a standard form, we can just jump straight to that form at the end there, which is what I'm going to do in this question. A squared in this case is 16. 2 times a times b, that's 2 times 4 is 8, times by 3 is 24, root 2. And then I've got b squared, so 3 times 3 is 9, root 2 times root 2 is 2, 9 times 2 is 18. In this case, there's a little bit of simplification to do. I need to put my 16 and my 18 together, which is going to get me what? 20, 34. And that's the end of that question there. Noting that I could have just written it down like this and done the full expansion, which in this case I'm not going to do because I'd prefer to just use the general form. One more question. If I have 2 root 5 minus root 17 and 2 root 5 plus root 17, what have I actually got there? Well, this is another thing that's in a special form. So let's just note what special form this is. This is the difference of two squares, where I've got the exact same numbers in both, but one of them's positive and one of them's negative. Just like the previous one, we would describe this as a standard form. In this one, when you multiply the parts, you've got a squared, you've got minus ab, and then you've got plus ab. And since you've got a minus ab and a plus ab, they just cancel every time. And then I've got minus b squared, hence the way we describe this as a squared minus b squared being the difference of two squareds. Now, once again, since I've looked at this and recognized that it's in that form, I'm not going to bother multiplying the whole thing out. I'm simply going to jump straight to that last line of working there. I'm going to square the first thing, and I'm going to take away the square of the second thing. So the square of 2 root 5 is 4 multiplied by 5. The square of root 17 is 17, and that's it. That's all I'm doing. 20 minus 17 equals 3. That's about that for that one.